Good morning. My name is Megan. I'll be talking about heat transfer mechanisms today. So let's start off by talking about heat and the basic idea behind that. The transfer of energy from a warmer area to a cooler object or area. And what is needed for a heat transfer to take place is the difference in temperature between two objects. Without this difference, no heat transfer can take place. Usually the warm molecules are heading towards cooler locations, is usually the direction of things. The main mechanisms of heat transfer are going to be conduction, convection, radiation, and evaporation. The main ones that you're going to see most of the time are the first three. They're generally the ones people learn in science class. But evaporation is thrown in there because it's used as a way of transfer in HVAC systems. Heat transfer in HVAC systems. The difference between all of these is the most obvious as we look through them because they all have different methods of transferring heat. You'll see conduction is used to transfer heat through material, convection through water or air, and radiation through electromagnetic waves. Evaporation, like I said, is a little different, and that's why some people don't group this in with the main heat transfer mechanisms. But like I said, it's very useful in heat transfer and HVAC, so I'll be grouping it in there today with the rest. All right, this is the basic concept of conduction. It's the transfer of kinetic energy from a molecule with a higher temperature to a molecule with a lower temperature until equilibrium is reached. And this is kind of the basic idea of heating a pot of water. As you can see, heat transfers from the flame to the pot, which heats up the water and the handle. Here's Fourier's equation. Use it to find thermal conductivity of the material. Copper and iron have a much higher heat conductivity than wood, as everyone knows, and you can use this equation to figure that out. Convection is the movement of heat by means of air or water, which is called a current. Here's a picture of that for the weather. Kind of shows the easy process of that. There's 4 different types of convection applied through density differences. Natural convection, forced convection through pressure, and then you can use boiling and condensation to promote heat flux as well. Here's Newton's equation. You can use that to find the heat transfer coefficient depending on the type of fluid and the fluid velocity. Here's radiation. Is the transfer of heat by electromagnetic waves. So the sun or the heat that radiates off of a fire, anything above the temperature absolute zero radiates heat of some sort. So remember that. And its a way of travel is through electromagnetic waves, similar to radio frequencies or your microwave. Here's a picture of evaporation. It is the energy carried through physical changes of water. Fluid can be used to transfer heat by absorbing the energy used when water transforms into vapor. And for HVAC, they use evaporator coils for ACs and refrigerators. These are some of the main heat transfer mechanisms they use for HVAC. And specifically, it comes to buildings and enclosures. Forced ventilation, heat pipe technology, passive cooling, and enclosure or air conditioning. Enclosure would be considered like refrigeration. Forced ventilation, cooler air is drawn up from the bottom of the building, and warmer air is discharged to the top of the building using fans. Here's a great picture of some of the ventilation they've instilled in this building, and since hot air rises, they're grabbing the air from the bottom of the building and releasing it from the top. The bigger the fans, the more air flows through the building. My uncle, he redid all of the ventilation from the bottom and the top of his house and installed a really big fan, and you can feel the breeze in his house all the time, like you're sitting outside. Here's a picture of heat pipe technology. Furnaces and air conditioner use heat exchangers to accommodate to a comfortable temperature. And the only energy really needed for this kind of system are small fans to circulate air around the hot and cold ends of the heat pipe. All right, here's a picture of the evaporator condenser coil used to regulate temperatures in refrigerators and air conditionings. As the hot vapor passes through a condenser coil, it liquefies and gives the heat to the air outside of the enclosure. This is a really great picture explaining kind of the process of that. Here's some passive cooling techniques. They've prioritized this in a lot of different countries throughout the world, like Australia, where they use landscaping, insulation, reflective roof plates for daytime heat gain, and they use landscaping and shade to help cool buildings down. It's useful to take into consideration the climate of the area, so you can instill productive passive cooling and heating techniques, which in the long run involves zero energy for regulating temperature. In what ways can you use nature to help regulate the temperature of your house without utilizing much energy? Up north, you'll see houses that are built into the ground or through a hill for regulating temperatures of basements or entire houses. So that's really useful. Or building up to trees for shade. And sometimes it costs a little extra at the beginning, but it saves money in the long run if it's for investment purposes. Here are some passive cooling and passive heating techniques that you can use going forward. If designers and builders could focus more on these aspects, then it would change the direction of society's desperate need for the abundance of energy just to remain comfortable in the building. And remember going forward that it's important to design and build in response to the climate. Thank you for listening, and good luck with Chapter 15.